We're told as children that if there's a fire in our house, we're supposed to get out of the house and call the fire department. But in spacecraft, this isn't an option. There are no fire departments in space, and you just can't walk outside. A bad fire actually happened on the Russian Mir space station in 1997. We need to understand fire behavior and microgravity so that we will know how to avoid the fire as much as possible and survive it if it does occur.
Now, Dr. Olson, it sounds to me like you're saying that fire behaves differently in space than it does here on Earth.
Very differently, Jennifer. Gravity is such a dominant force in fires here on Earth that we take it for granted. For example, a wildfire is very gravity dependent. On Earth, wildfires spread uphill much faster than downhill. The reason for this is that the heated air from the fire rises up the hill and heats the fuel, like the grass, trees, and shrubs, ahead of the fire. Blown into the wind, the fire's reach is long, and it can spread very fast over the nice warm fuel. On the other hand, going downhill, the wind is fresh, cool air being drawn into the fire to replace the rising hot gases. The vegetation remains cool until the flames are very close. The flame's reach is very short, and it takes longer to heat up the cold fuel, and the flame spreads more slowly. In space, fires like to go in the exact opposite direction. They like to spread against the wind, while wildfires are blown by the wind. Because hot air doesn't rise in a microgravity environment, the only airflows in an orbiting spacecraft come from ventilation fans, cooling fans, and crew movements. A fire, given a choice in this microgravity environment, will preferentially spread into the fresh air. The flame doesn't have any control over the airflow, so it has to seek out the fresh air. The wind-blown or downwind side of the flame is only receiving polluted air that contains smoke and carbon dioxide, but not much oxygen, because that's already been consumed by the upwind side of the flame. So when the air flows from the ventilation fans are low, the downwind side of the flame can't spread at all. Even though it has fuel and heat, it doesn't have the oxygen. In a microgravity environment, if we reduce the airflow, even the oxygen-seeking upwind side of the flame has trouble getting enough oxygen, and it breaks up into little flamelets.
Okay, so how do you measure or collect data on these little flamelets?
In our experiments, we use this droppable wind tunnel to study the effect of airflow on the flamelets. When we drop this miniature wind tunnel, we can get brief periods of microgravity here on Earth. We can measure the effect of airflow on the flame by applying a very low-speed airflow to a flame as it spreads across a thin sheet of paper. As it spreads, we can measure its position as a function of time and plot time and position on a graph. The following graph allows us to compare position versus time for flamelet tracking. The x-axis, or horizontal axis, is the time measured in seconds, and the y-axis, or vertical axis, is the position of the flame measured in millimeters. This graph represents a flame that starts out uniform and after 5 seconds of travel breaks up into flamelets. The point 00 represents the location where the uniform flame breaks up into flamelets.
Okay, Dr. Olson, from this graph, there appears to be a linear relationship between position and time. Why is the slope of the line representing the uniform flame steeper than the line representing the flamelets?
That's a great question, Jennifer. The steepness or slope of the line tells us the spread rate or the velocity of the flame.
So let me see if I get this. As the slope of the line decreases, then the spread rate or velocity decreases.
That's correct. For this particular test run, the velocity of the uniform flame was calculated to be 3.4 millimeters per second, and the velocity of the flamelets was calculated to be 1.0 millimeters per second. Although the flamelets spread more slowly, they're very hard to detect. And they can flare up into a big fire again if we turn up the airflow. Imagine if the astronauts put out a fire and then turned on the air circulation system to clean up the smoke. The fire could flare up again.
Wow, I can see how important your research is to the safety of the astronauts on board the International Space Station and the Space Shuttle.